Hello everyone, so welcome to another video on analyzing a cybersecurity scenario based on a story in the register. So this is actually quite a complex story with a simple scenario, but a very technical and very specialist asset in question, and also a very complicated theoretical attack. So we will discuss this. I will show you how to go about this in 3 steps. You start with a preliminary analysis. You will then do the actual security assessment methodology as a means of understanding better the various ingredients of the story. And finally, we will discuss it. So before we start with this, if you subscribe to my channel and if you give this video a thumbs up, then it means that you will not miss out on future videos posted on similar topics, and also it will increases chances for other people to actually benefit from this video. Thanks a lot. So as the first step, I recommend reading the title very carefully and then try to understand any technical buzzwords that don't make sense to you. You can look them up on the web or elsewhere, and also to just get used to some of the the specific vocabulary that might be used in the article, just to understand what it actually talks about. So if you look at the headline, Intel's SGX cloud server security defeated by $30 chip, electrical shenanigans, then what you learn from this? I mean, it seems to be to do with cloud servers, cloud computing. So we probably learn from this that the security domain would be cloud computing. We talk about something called SGX. Now, this might not mean much to you, so we'll have to clarify what that is. It seems to be produced by Intel, and it talks about a defeat, a security defeat. So that sounds like maybe it's very difficult to find a control for this. Maybe it's an unresolved problem, a security challenge. And then this, the defeat should be done apparently by an attack based on electricity, on hardware attack. That all sounds quite strange at first glance. And then look at this word shenanigans. What does that mean? So let's have a careful look at the vocabulary now to better understand this. Let's start with the first buzzword. Let's start with the SGX. If you scroll down a little bit, then you can find an explanation of SGX as being a specific architecture, a specific implementation of secure enclaves done by Intel, apparently. So what's a secure enclave? You might not have heard this before. So this is actually to do with memory protection, with operating system protection in the larger sense. And it's the idea that you would somehow protect an area in your memory which might contain data, it might contain running code, through encryption at the lowest level, as microprocessor level. And this area of memory then would not be available to any other process, even at a higher privilege, other than in encrypted form. So that's what a secure enclave actually is. These secure enclaves have been quite popular with, for example, cloud server providers, because they give them a bit more of a guarantee, that the information is encrypted and protected, and it would be very difficult for both external and internal attackers to actually get hold of that information. So it's a really good contribution to cloud security. And here the SGX then is the Intel specific implementation of such a secure enclave. And that's what the story is actually about, the security of these enclaves. There's another interesting term in here, if we search for it, multi-tenant computing. So let's find it. Here we are. Multi-tenant computing is an architecture that's typically used for virtual hosting in cloud server architectures, where we have the space for different users effectively sharing, of course, the same server. It's the idea of having several apartment flats next to each other. And the problem might be if there's, let's say there's a leakage of, let's say, a pipe. It would drop and it would eventually create a problem in the apartment underneath, wouldn't it? So here the same idea is that some computer attack, cybersecurity attack on one cloud space might actually leak into the other one. And that's one of the main problems, a typical threat in cloud computing. This is one of the reasons why people might want to use the secure enclaves to protect themselves against this problem. And then there's one more term in here which is maybe surprising in a cybersecurity story, a bus, a data bus. So what is a bus? And that's used in computer architectures, and it's simply a communication system linking different parts together, different components, and they can exchange data. And it's quite unusual that such a component would be target of a cybersecurity attack. So once you've clarified the technical terms, I just point out a couple of other unusual words which are kind of slang, and you find them quite often in, in kind of media reports or news items. So shenanigan, what's a shenanigan? It's a secret or dishonest activity, basically. You find the word boffin. What's boffin is? It means a researcher, kind of potentially, a geek, a nerd, but it's not meant to be pejorative. So it's meant to be kind of positive. And here it's to do with cryptanalysts, basically. These are researchers that are trying to find novel attacks. So then once you have kind of clarified the terminology and the technical terms and you understand them, then you need to proceed to the next step after this preliminary analysis and actually do the security assessment. And that will really help you to understand what's going on here. So the first step is, remember to identify the security assessor. So what is the kind of role of the people who have been doing this attack? Who might it be useful for, or who might be warned by it? Who is it targeting? So what do you think it is? And now might be a good moment to pause the video and think about the security assessor. I would say in this story is that, the purpose of the story is clearly a warning, and it's a warning to two different types of people. It's a warning to customers of Intel, so people who are actually, using these SGXs for their hosting of cloud services. They should be alerted to the fact that there is a problem, actually, that there's a way of attacking something that previously they probably thought is pretty much safe, the secure enclaves. And also it would be an alert, I think, to Intel, because they obviously created this problem by designing their hardware effectively in such a way that it could be attacked. And they haven't really released any patches to that yet. So it's a sort of double message. So in my opinion here, then the security assessor is probably the researcher. So it's from the point of the cryptanalysis point of view, who are demonstrating that there is a problem with this product, which obviously can affect both the vendors and the users. So having identified the security assessor, it should now get a little bit more straightforward, because we now need to focus on the critical asset. And I think that's pretty clear, because we've been saying this already. It is clearly this SGX thing. So it's basically at microprocessor level, it's hardware. So we're actually talking about a hardware asset, part of the microprocessor. So basically the SGX asset. And now we need to think about the security requirements, the security goals that are important here. So typically because they would be threatened by the attack. So in this story, all you need to do is you need to actually look at the second headline, where it talks about something that I haven't mentioned so far, a vault pillager. We'll come to that in a minute. That's actually the attack here. This attack breaks enclave confidentiality. So actually the headline is giving it away. So it is a problem with the confidentiality of our SGX hardware asset. So now if you want to understand the next step, it's all about vulnerabilities and threats. Yeah, it doesn't really matter which order, but it's really important that you see the difference between threat and vulnerability. These are two entirely different things. So if we look at the story and we scroll down a little bit, then actually we pick up on the word vulnerability here. And it talks about a related attack, plunderwall. So apparently the same people or the same team of boffins at the University of Birmingham did do some previous work on attacks which were actually written in software, and the attack was creating problems with the confidentiality and exploited a vulnerability which was in the hardware. And now what they're saying is there's a similar attack now. This time around it's a hardware attack, and it has similar effects. So it is basically still addressing a vulnerability that is present in the design of the SGX system. Yeah, so it's all about a vulnerability in the hardware. And that's very unusual because normally when you think of hardware vulnerabilities, we think of physical attacks, how we could, remove parts, we could destroy parts, we could steal the whole hardware thing. But here it's to do with how the thing works, how the hardware is designed, and there is a vulnerability. Very unusual. So now that we've identified this vulnerability, remember there's only a problem if we can actually find a matching threat. So if we have this match, then you could launch an attack that would exploit the vulnerability. So here in this story, clearly those boffins, they have created an attack type, which is an implementation of a threat, which is based on hardware. And it's difficult to understand really how this works. It's explained only in one sentence here: by injecting messages on a specific type of bus between components inside, this microprocessor. And that's basically, that's the attack here, right? Which they call Volt Pillager. And it's an attack that requires physical access. So it's not a remote attack, but the impact is potentially quite dramatic. So remember, once you've identified vulnerability and threat, then it's important to come out with an appreciation of the risk, the resulting risk. And so here what you need to do is you need to figure out the impact of the attack. And here in this case, the impact could be to actually, very similar to the plunder vault attack, to recover, look here, secrets like encryption keys. And obviously once you've got access to the encryption key, then you could decrypt the data and you would undo this whole protection idea of the secure enclaves. So then if you wanted to judge the resulting risk, you have to sort of balance out this, in my opinion, relatively high impact of the attack, but then also, I guess, the more specific nature of the attack. So there's probably a reasonably low risk of this actually happening, a low likelihood, because the exploitability of this vulnerability is quite complex. It's quite difficult. So you need to just for yourself then decide, whether you think that's medium risk maybe or low risk. That's your personal opinion. But as long as we can see that it's a high impact and perhaps low likelihood, we have given a sufficiently detailed assessment of the risk. And then the last step is to think about controls. So here the story does mention a number of mitigation techniques, as they say. So the paper touches, so that's the academic paper which describes the attack, touches on possible mitigations, and They look quite complicated, and they seem to be difficult actually, because basically you need to redesign parts of the hardware, and that's a huge deal, you know. That's a huge problem, and then you can't easily upgrade existing hardware. You need to replace it physically. So it's maybe not a surprise that Intel is not so keen on doing this. So Intel here apparently is simply just saying, well, this is out of our promise. You know, we have never said that people can get so uncomfortably close, physically close to the hardware, so that they can do this kind of attack. So then really the only thing you can do is basically just not to use that feature. So stop using the Intel SGX architecture with that vulnerability and find something else. But even, you know, even other types of hardware and other companies might be prone to similar attacks, apparently. So really there is no easy answer to this question. So now, after having analyzed the critical asset, the vulnerability, the threat, and the risk, and the controls, we can now find a sort of final discussion of this in terms of the bigger picture. So what's the security domain here? What's the application area? It's about memory protection, which is part of operating system security, isn't it? And the particular use here was actually in cloud computing. So it is also cloud security. You could even say it's a virtualization security in the broadest sense. And what were the main challenges here? So the problem that it's very difficult to actually find a control. It would involve redesigning hardware, very difficult. It would be a huge effort to do this. And also maybe the attitude of the vendors towards that vulnerability, because they are reluctant to actually recognize it as such. And that's a big problem. And then maybe the last thing you might want to do in a discussion is to establish context to other things you might have heard about. So you might have heard about the Meltdown and Spectre attacks, which were also hardware-based, and they were looking at different other features in standard Intel processors actually to do with performance accelerating of code. So this is clearly related to that sort of type of attack. And what would be a lesson you could learn from this story? So if you pause the video once more and think about, you know, what are we learning from this? And there are several answers to that question. So in my opinion, we learn that there's no such thing as complete security. I always explain that you can't guarantee security. So even assets which have been used for many years could well have a hidden vulnerability, and here the researchers have discovered such a thing. So really the security is only, you know, deemed existing if it stood the test of time. Only then we have an industrial strength security, and here there's clearly a problem. So I hope that's been useful. It's worth reading the story again, researching the different buzzwords a little bit more, and very soon there'll be another story for you. Thanks for watching.